environment. And the final one is the secondary visualization area, where you have elaborated information through a text message or by seeing the historical positioning of people. And what are the main features of this environment? To start with, this real-time visualization and placing each person on the map or on the plan. And if we want to have a real-time visualization, we would click and we would see a red shadow and a red shade. And if we select one user, on the bottom right, we would find all the positions where that person has been. And next to that little map, we see a text box where we see in what building each person is and any incidences. If we have not selected a person, we will see the information for all of them. Controls to adjust the speed of the simulation. Controls to start, stop, or restart the simulation. We can also declare safe rooms, for instance. We can identify some rooms and we can tell the server or the system to inform us when someone goes into that room. That will be in yellow. If someone goes into that area, the system will advise us with a text message and by adding this red crown. And we can also see the list of information of people and all the rooms where he or she has been and whatever incidences have taken place. This environment has been designed to facilitate the inclusion of new services, because it will depend on where you use that system, of course. This module division was done through the model site controller system that allows us to make a clear difference between data control and visualization of data. And here we can see how the layer of model contains information about the visualization of people and the rooms where they have been. The control layer is made up by control elements in the environment, and the view view layer includes different visualizations of the environment. Now, this model stores information in the following way. One scene is made up by people, building, all the stories of the building in each one of the rooms that story or floor contains. How do we implement this? The simulation engine moves people around. It starts in a given position, and at each step of the simulation, the position is being updated randomly. This can be modified while the simulation is on. This is a Java-based system. It's multi-platform, it's object-oriented, and it facilitates web integration. But at the same time, there are two execution threads. One updates the position of each person and changes the model, and the second thread reads the model and visualizes changes in each one of the views. Here we can see the matching of the different layers of this model view controller, the classes or kinds, and the links. And to conclude, let me underscore that we have submitted here a follow-up and location system that solves the problems that global positioning systems are not able to solve. We have presented a multi-frequency differential location technique that is still on a basic state, and it requires important efforts to make it operational. And we have also introduced a simulation tool that can be used as an interface in places where people need to be monitored. And as a future line of work, we propose to analyze comprehensively these technologies for indoor location and to add new services to our environment. Thank you very much for your attention and for your patience until the end of this final conference of the day.
Muchas gracias.
Thank you. Well, you've been very brief and concise, so we will have time for a few questions. I could start. Somebody here is desperately waving hands for a microphone. I wanted to know whether Well, it would appear that the advantage it offers vis-à-vis what I know is that the installation is relatively simple. Is the antenna per building? What would be the frequency range? I'm unable to provide you with that information. I'm sorry, because it's just simulation at the moment. We're just simulating results. So obviously there's difference in frequencies, and we can know that. But now the scope, the range for frequency, I'm still unable to provide you with that information. I'm sorry. I suppose this will this will be limited by the potency of, or the power provided by the aerial and the emitters. What would be the error margin? Would that also allow you to make the system an access control? That is when you're in front of a door that it opens depending on the person. Well, this technique works with interaction with the medium, so it depends very much on the medium. There will be a different decision taken. And my final question, you say that it's needed to customize the medium. Would this change depending on atmospheric conditions? Once it's gauged, would that remain gauged? It depends. If it's an open, well, if it's outdoors, obviously the weather events would have an influence. And if it's an outdoor system, if it's indoors, maybe not so much. But when it's outdoors, yes, definitely. Thank you. Well, I also have a question. We have we did something with Wi-Fi triangulation indoors, and it was regarding location of blind people, regarding locating blind people, and we have seen that the accuracy, it was, well, quite low, like 3 meters only. And we've also seen that this accuracy is very much related to the echoes, voices, people present. So all of this was relevant. So we decided, obviously, it wasn't an optimum solution, but it would appear that your system offers different possibilities. Well, we've been also assessing this type of triangulation technology. We run some tests with a higher number of antennae, and the rebouncing effect is very problematic. So, because if it is one single location, it's okay. But if we go to different rooms with this partitions and walls in between, that is more complicated. Well, the other gentleman says, we've done it in railway stations, in large surfaces, quite open, and of course it was very different, depending whether it was rush hour, where there was a lot of people, it was very crowded, as opposed to when it was quiet in the railway station. There were some patterns and some influences that were beyond our control, and we reached the same conclusions, by the way. We need to work harder, obviously, that's very clear. Do you have any more questions? Well, more than a question is probably a comment. We've also run some tests in the level of signal, both in Wi-Fi and non-Wi-Fi. But one thing that we run that maybe it would not work in the railway station, with ultrasound, you would be as accurate as down to centimeters, but the range, it's very limited. But you can go up to 10 meters and quite accurately, even down to centimeters. However, the device is kind of bulky, but it's an alternative for this sort of precise measuring. And we also want to launch a standard, an ultra width band that would provide us special solutions, but there's no chip supporting that application with the ultra width band. Well, I think that's it. Let's call it a day. Thank you very much for staying until the very end. Thank you.